Yeah.
Yes. And now we will move on to the next speaker. Jochen Emig is a Google developer expert on Google Assistant and founder of the ONSEI. We had the pleasure of meeting a few months ago, and Jochen will talk about conversational UI interfaces, voice interactions, and let me say only from my side that this is one of the most underrated technologies that you can actually learn very, very fast and then use on your mobile devices, use on your tablet. So, Jochen, the speaker is yours. Show how amazing the technology is.
Thank you so much. It was a really kind introduction. Also, thank you very much for everything you're doing here. This is an awesome event. I'm glad to be part of it. As you can hear my voice, fortunately, my family, my partner, my daughter, and I all are in quarantine right now. So that's why we're a little bit, yeah, if I sound a little weird, yeah, that's why. But everything else is great. I'm super happy to be here. I've been really looking forward to this talk. I've been thinking what I should talk about for a little while because, like Anna said, I truly believe that voice technology is a way of us for the future, how we communicate with machines. And if you think back, I mean, when I did my master's degree in the facility in the building, there was an old IBM punch card machine. I forgot the name of it, but this is how we used to interact with machines. I have no idea how. I've never used these machines, but it was for me a reminder. On the same sense, back then, I am dyslexic. So for me, often typing and writing essays was fairly hard. The one way I've really early learned how to deal with this is with dictating everything. So for me, using voice as an input was always kind of a part of it. Once I found technology, in the 2000s with Dragon from Nuance, I spent quite a lot of money so I could start dictating in high school and in college. And my whole master thesis was equations I wrote by hand and text I dictated. And I'm realizing I'm not sharing my screen. I'm sorry. I hope you guys can see my screen now.
Yes.
Yeah, okay. So that's me. While I was finishing up my master's, I built Amazon was just starting with the Google Assistant. Amazon was starting with Amazon Alexa. And because of my previous interactions with dictation and computers with voice, I really started building a shine to it. And I started building games. I published my first game in 2016, and it really just was for me a new way to interact and have fun with games. Obviously, I like to play in games. I love games from the 80s where it's mostly typing inputs, so like adventures where you like really write move up, move left. And these are things you could do with voice. I have games I've played in 2016, I built in 2016, I still played thousands of times today. In 2017, I started building Google Actions, similar because it was a new interface. Google Actions were working on Android phones, which means we had a screen and we really could start building multi-modular interfaces where we use a screen, where we use voice together in this whole package. And that's why I really became a fan of Google Actions. Obviously, today you can also do this with Alexa, but Google was, for me, the front rider here. One thing I wanted to talk to you about, because it's something I've been working on since 2019 and I'm interested in, and I was going back and forth what topic I should talk about. And this is just something that comes up in the news and I wanted to give you my opinion. So I started working with GPT-2 in 2019, which is a large language model. In 2020, with one of our clients, we started working and building Jochens applications. Jochens is also a large language model. And then in 2003, 2021, when GPT-3 came out, I started working with GPT-3, and this is what I'm going to talk to you a little bit about today, and how to connect this to Google Assistant, and how to make it all into one system. Just as a small reminder, what is actually a smart speaker, so that we can go around it. Smart speaker in traditional sense, so if you see the ones behind me, they have a microphone, have a speaker, and there's obviously a lot that happens in between. So in the first step that we use is we have an ASR, which is the automatic speech recognition. It's pretty much responsible for two things. It has running a wake word engine that listens for certain sounds that starts the whole process. So for example, the wake word Alexa, it obviously is looking for similar patterns and sounds. And in the same sense, once it actually starts recording live, it also translates everything from text to speech. Then from speech to text. Next thing is the NLU. The NLU is the part which is responsible for thinking, trying out what intent the user is actually trying to do. So the way in a programmatic way, as you can say, is we transfer the one string into an object that has more data with it. Dialogue management and knowledge graph is what most people then actually program when they come to voice. It's how to deal with the response, how to get the data out of it. For example, if you put a weather skill here, you would put everything, you would get, for example, open API weather APKs, and then you get everything together. You would give it over to the natural language generation that then creates a sentence again, because this is actually a fairly complicated part. You want to have voice the way people understand it. You want to have it natural. Yeah, from there we go to text to speech. It transfers everything into speech, and that gets played back. So the big three things that is changing right now in the industry a little bit is the NLU, the dialogue manager, and the NLG. So as also a little side note, the reason voice I think is so fantastic is because we can talk a lot faster than we can type. We can give out a lot of information via speaking. We can say commands fairly quickly. We can have conversations. It's also one of the most natural ways to communicate, because as I can see by my little girl, it's the first thing how she tries to communicate with us. She says syllables now. She starts creating her own words, and she gets really excited when we start understanding her. The same way, it is also a little bit complicated for us to listen to a lot of information. So my example is one of the first applications we've built at ONSEI is a public transportation, how to get around Germany. So while you could ask, a lot faster, how do I get from Berlin Hauptbahnhof to Zoo tomorrow morning at 9 a.m. These are four informations you usually have to, in the app, write out. So you have to spell two names, and you have to go through a date picker and a time picker. That's the easy part. But when then the application tells you, okay, at 8 a.m. you have to take train I to train B at that station to train C, it becomes hard for us to remember everything. So that's why natural language generation is something we've focused on quite a lot, and find good ways how to communicate and give the information back so that a person can remember it, understand it. And this is really, that's why I also love the multi-modular approach that Google has, where you have a screen and you can really use advantage of the screen. But like I said, these three things are changing quite a lot right now. And the reason why are these large language models. A large language model is the idea behind it is AI model that is trained where you can ask anything. And I figured, why wouldn't we ask GPT what GPT-3 is? And this is actually a real response from GPT-3. So it's a large language models that shows general intelligence, but only when trained on private data sets. We'll go into that a little bit more, but let's ask, what is a large language model? A large language model here, as we said, is a statistical model that pretty much works the way we know autocomplete right now. So when we start with, as you saw with Google for years, or when you do something in Google search, you start typing something in and you see all the other responses that might, that already think you might be asking because other people have been asking them. These large language models, just as GPT-3, are actually fairly similar, just on a more, on a grander scale. And everything is just a prediction of what might come next. These models are so big that you can actually think that you're having a real conversation with somebody else, because there's a good chance that a similar conversation was had before that it can build on. It's more, so currently we use it mostly for, you know, Q&A and small conversations, but the goal is really to have a long conversation model. Like I said, large language models work by predicting the next token. A token, the idea behind it is that when you train these things, when you train large language models, you tokenize everything. So when we have these texts, we tokenize everything. I will go over what a token looks like in a little bit. And after just having a few examples, we can then recreate these machines and how to, sorry. And you drink a really quick sip. Yeah. Once we have once we have everything tokenized, we learned everything, and then giving out, we tokenize everything new coming in, and then we can predict these outcomes. The one big thing I really want to talk about is, and that's one thing that is often misunderstood, these large language generation models are machine learning models. So their whole concept is they want to give you an answer. Like any AI models or machine learning models, they're trained to give you an answer. That doesn't mean the answer in your opinion is right. The next thing that's really important is because a lot of people only connect them directly to an assistant without a dialogue manager or an intent system in front of it. Yes, when you ask the mathematical questions like here we have, like I have here, there's a good chance the answer is going to be wrong because they're not mathematical models. They are language models. So, you know, this is the my time I lived in the US, that's 5 miles per hour. But when obviously the answer should have been 336 miles per miles that you can travel in 3 hours. But here it tells us it's 202.5. And the reason behind this, it's trying to give us an answer, but it's trying to give us a text answer, and it doesn't do the mathematical. Oftentimes, when you ask what is 5 times 5, simple math questions, it will get completely right. But it's an assistant, and it's not an assistant, it's a language model. And you should never rely on it to do accurate information, up-to-date information, or information that is based on question that actually, you know, need computation behind it. The next thing is when you start using GPT-3 and any other model like that, there is always this warning because they use all kinds of data. And we will talk about a little bit later where the data comes from. But obviously this, when you talk about data this large, it ran through information and filters, but it will learn everything. And it's your responsibility to make sure when you use large language models that the response that comes out is the response that you are okay with, and that is part of how to train it. And for this, we actually use filtering in both the input and output. That means when a user asks a question, we filter this question, make sure that it is a question we actually do want to answer. So imagine you're sitting in a car or you're talking on your phone. There are people out there who ask questions we just don't want to answer. That's the honest answer to it. The same way, we also check that when the response comes back, this is a response that we are okay with, that is with us on brand, that we try to remove as many biases as possible. And it's really, brings over the persona that we want to bring over. So let's talk about the size of these models. So I talked about GPT-2 in the beginning in 2019. These models are getting massive right now. Switch Transformer, by the way, is the model from Google, their new one they're currently bringing out. And it's, as you can see by that, they're really getting a lot bigger. The token size is getting incredible. And that's why it's also so hard to really get a good clean data set, because the data is just getting too big. And here's why. So I don't know how many of you guys know Common Crawl. Is an open, anybody can download it. It's available on S3, it's open source, but it's pretty much the web. So there are bots that go through and collect the web. And the next thing is web text too. It's also open, books that are linked in, and Wikipedia is 3%. And the reason I wanted to bring this up, if you think Wikipedia is only 3% of these large language models, and I mean, for me, Wikipedia is massive, but for these large language models, it's just 3%. That shows you how big it is. And these is also quite a few issues that come with it. So the first thing is, for the last note, the last version of Common Crawl was released in April of last year, and it is 320 terabytes to give you a scale. It is always a snapshot of the web. So when you ask GPT-3 things today, I believe they used, their cutoff was the one that was released in October 2019. If you ask them who is president of the United States today, it will not be able to give you the answer. The president came in 2020, so no, 2021, 2020 was the election, but it won't be able to tell you who's president today. It will actually tell you probably it's one of the previous presidents, probably Donald Trump, because it was the previous president. He was the previous president, unfortunately, but that's my point. There is a snapshot. So if you ask a historical thing or things that don't change, like what's the biggest mountain in the world, you're going to be fine. If you ask current events, this is not going to work. However, what you can do, what we do is when we use these models, we feed additional data into it. So when we have clients who want to have chat conversation on a chatbot or on a Google Assistant, and they wanted to feel a little bit more natural, we use the GPT-3 abilities to generate language output, but we feed additional data in. So if somebody would ask, who is the current president, we would give the question to GPT-3, but we would also feed the answer and only rely on GPT-3 to give us actually the result back in a written form that of the metadata that we gave. So we would get the correct results. The next thing that comes with these large models is the cost. One thing that doesn't get spoken to a lot, that currently it's just the way it is, unfortunately. The cost to create these large language models with these big databases is massive. So you can drive a car around this Earth probably 2 or 3 times and create the same amount of CO2 that it costs training this model once. There's a lot of great, excellent effort going on right now to get the cost down, to make it simpler to generate these models. So this is, for me, something that's really interesting, how to get these large language models in a better way. And the other issue that we have with these large language models is biases. This is something you really need to be careful when you start using them, because it is using Common Crawl, and everybody who writes a website pretty much has to say in Common Crawl. So you need to make sure that when you use these large language models, that you make sure that the everything coming out is according to your, I would say, morals and everything. And that's why we have our filter systems, to make sure that everything is okay, because the biases are there. Why am I talking about GPT-3? Because there are a ton of things out here, and there's a ton of great startups. The reason I'm talking about GPT-3, because it is one of the bigger ones, and it has a public API. It has a great community support system. It's super easy to get started with, especially since last October, because it used to be invite only. Now anybody can use GPT-3. And the other thing that I like, it's stateless. So you are responsible for creating your own context. You're responsible for sending everything there and getting the correct response. There are things that are not so great about GPT-3 anymore. So I talked about the biases. It's like I said, when you start using large language models, it's something you have to deal with. You really have to check to make sure that the biases are filtered out, or that you are comfortable in using them the way they are. If you ask simple questions, it's fine, but other more if you use, questions about political parties or anything like this, biases really do show. There's a lot of unusable information in there, because, like I said, it's a snapshot from a certain time. There are responses that just more on niche subjects that don't make sense. So again, those you have to filter out. I mentioned the CO2 earlier. Obviously, there's also money involved. So GPT-3, because these models are so large, it's fairly expensive. When you sign up privately, you get a fairly good. I don't remember how much it was, but you get credits, so you can try it out. I think one reason that GPT-3 or GPT-2 for that matter is one of the more successful ones in the front. They used to be a nonprofit company. So Elon Musk was one of the founders of OpenAI, and this was back when he also released all the Tesla patents for everybody to use. OpenAI used to be nonprofit, was great and everything. However, with the release of GPT-3, OpenAI became a for-profit company, and because of this, Microsoft right away, probably because of this, Microsoft purchased all the rights to the model. So you can play with it, you can do everything, you can fine-tune your own models. But for you, it's no longer, you don't own it. So in GPT-3, you could actually download everything, run everything on your servers. That's not possible anymore, which is really, in my opinion, is a sad part. There are awesome open source alternatives. Fraunhofer is currently working on one that we're trying to help, the OpenGPTX, where we're also going more for international languages. I know I'm running late on time. I'm going to try to go really fast. Sorry, I have quite a few more slides actually. Okay, this is how tokens necessarily work. So just because tokens are going to come up a lot in these topics. So when we have women Techmakers spelled out, pretty much in the English language, you can often say that a token is a word. But this is just the way the tokenization works to get the predictions done. When you have German language, for example, or you write things together, then the tokenization, what it does is takes words apart to better create the models of seeing what comes next. So here we have 5 tokens and we have 15 characters. The next part is what can GPG3 do? You can ask any questions in open chat and it will give you an answer, but it is not by far what it can do. GPT-3 is so big and so well trained, you can actually translate German to English, English to German, based on this language model. That was impressive. The next thing that's impressive, I don't know about you, but I'm a Python first developer, love Python, but as you know, I wrote Kotlin, I write Java, pretty much anything that is needs for projects, but GPT-3 can actually translate code. It can translate, you can write a function in Python and it will translate that code functioning to JavaScript, for example. And this is something that is so powerful and so great. It can also, what we're trying to play with, do code reviews. It can, I'm just going to say a few examples and then go to the last slide. I've trained a model in German. There is a kids publishing called Drei Fragezeichen for those who grew up here in Germany. It's about 3 teenagers trying to solve crimes. A lot of Germans have read it when they grew up. I trained a model on one of the characters, so it actually GPT-3 creates whole new stories based on those characters for me. And it's I can talk to a character that I grew up with, and it's just kind of crazy that that character in his words gives me answers. So I was going to go into, because I'm sorry I'm running out of time, I was going to go into how we connect this to Google Assistant and how to bring everything forward, but I don't want to take up too much time. So if you have questions, I would probably go to that and go to my last slide.
Thank you, Jochen. I published links in the chat if someone was interested. There are YouTube tutorials, there are code labs.
Yeah.
Just to know that there. But if you could reply to one burning question. So
yes.
One common concern is that people feel that that smart speakers keep on hearing them all the time.
Mm-hmm.
Could you share some insights if it's similar on Google Assistant and on Alexa?
Yes. So there's 2 parts to it, and I kind of mentioned a bit in the beginning. So yes, there is a microphone in that system, and there's a little local processor that compares sound waves, but nothing gets sent to the cloud, nothing gets analyzed anywhere else except on this little box that's trying to compare a sound coming in to a sound it already knows. Once this is done, then you see usually in Google Assistant and Alexa, the machine will light up. And by that, once it's lit up, it usually then starts transferring in Google Assistant up to 8 seconds max of data to the cloud to see if anything is, if there's something that you want to actually do. So, when you ask, can you ask for the weather, then it will start doing a transfer. The really cool thing is with Android 11, this is actually now done completely locally. So if you use a Google Assistant on your phone in English, German, and sorry, these are more language I'm mostly working on. On Android 11, this is done locally. So it can actually do a lot of processing locally. And if you have a question that can be completely done on the phone, like asking what time it is, none of the data will actually need to be sent to the cloud anymore. I personally, I mean, as you can see behind me, I have a lot of smart speakers. They are my passion, my hobby. I do not believe that there's any risks that you will be listened to. in that sense. It's just one last thing I would say to that, it's like the difference between a smartphone that you have in your pocket and a smart speaker behind us is usually it's a better microphone, so you can listen to a whole room, and so usually a better speaker so you can be listened to in the whole room. Yeah.
Awesome. Thanks for clarification and for taking time to present it. From my side, I also wanted to mention that this voice technology has been particularly useful for my family, because my elderly grandparents, they are not so proficient in using maybe tablets or typing and dealing with the ads that are popping up. But for example, this voice technology allows them to, like my grandfather is using that technology 10 times a day to ask how to cook a soup or to get some basic phone numbers. So I would really encourage you to get familiar with that. Maybe it will be beneficial for your friends, family, or colleagues.
Yes, I can only say that I have the same thing. I have a 95-year-old grandpa. He never had a smartphone in his life, but he talks to Alexa every day. He gets his news via Alexa. He gets the weather. He is bound to his wheelchair at this age now, and so he can't. If he wants to know what's on TV, he asks Alexa. If he wants to call me, he uses Alexa calling. If he wants to. It is so liberating to see people who don't have technology experience be able to use these devices naturally. And I will, unfortunately, didn't get to that part. I apologize for this, but I will send you some code labs, or Anna will send you some code labs, because they are fantastic, and you can really start creating skills really fast. And for me, it's the most rewarding thing is because most of the applications I've written, especially in the beginning, I never made money with them, but having seen thousands of people use them every day, especially the games. And one of my most successful games is called Color Game. It's a memory game where I probably spent a weekend writing it. And I have really tens of thousands of people all over the globe using it, and it's awesome. It's a rewarding feeling. Usually with Alexa and Google, they will give you credits, so you don't have any costs on server costs or anything like this. So if you write something, you don't have to worry about that. And it's a really rewarding feeling when you see people probably play it more hours than you used to write it.
Thank you for this overview.